I guess we're all set. Morning. This is for those of you who don't know yet, this is or wandered in early in the morning, this is the DConference 2013. Finally, we made it here. There's a couple of housekeeping things. There's going to be coffee and tea and stuff served all day outside. The bathroom's around the corner. They've got power strips along the walls so you can charge up your equipment. And there's free wireless, no password.
FB guest.
What?
FB guest.
FB guest. Okay, so we're all set on that. Okay, well, here's a what? Okay, I'm Walter Bright. Thank you. A bit of prehistory about D. Sometimes people wonder, where D came from. And if you do a search through old Usenet postings, you'll find there's some discussions that go back as far as the 1980s on a hypothetical D programming language, and it was just sort of envisioned as an improved C++. And you can even find some posts from me on that. But, kind of nothing really ever came of it. C++ came along and kind of buried any thought of making a successor to C. I left Symantec in 1999 and decided to retire, and that lasted about 6 weeks. I'm just not cut out for retiring. And so I started working on D then, sort of as a background thing, and it got more and more interesting. And it first appeared on Slashdot. Well, I told some friends of mine about it, and of course they posted it on Slashdot. So I actually had to start trying to make a working compiler out of it. D1 was released in 2007, the first version of D, and which coincided about the time we had our first D conference in 2007, which was hosted by Amazon up in Seattle. One common thing I've heard my entire career is you can't do that and it'll never work. You guys have proven that all wrong. It works, we can do it. We can build it. This is a picture of the attendees from the first D conference. Who was here at I know there's some of you. Awesome. That's the skyline of Seattle. So. Okay. D today, we've seen an increasingly rapid rate of development of the language since D1. As you know, we have an international, worldwide community of D, which wouldn't have been possible before the internet days. So how many of you are from out of the country? Yeah, about half, more than half. It's awesome. So we're doing what everyone told me was impossible. We're developing a major new programming language from the ground up, completely with grassroots support. And that is amazing. And I have the next slide will just show how freaking amazing it is that we can do this. This is our Kickstarter thing. In 1 month, we raised $30,000 to host this conference, which is just stunning. And in fact, we were even written up. Andre found an article and posted it on Reddit recently about one of the most successful Kickstarter projects. We have major sponsors. Of course, I want a big round of applause to Facebook for hosting us. Facebook providing the conference space, the logistical support, and the food and all that. And we have Sociomatic. We have 4 people here from Sociomatic. Yeah. Well, there's Don, finally. Sociomantic? Okay.
Spell that Y on their front
My fault entirely. Remedy Games is another sponsor, and we have Manu here. Where's Manu? Oh, there he is. You may know there was a big talking about Remedy Games a few months ago when we built the user-defined attributes and some other stuff. So we're proud to have Remedy Games as a sponsor. And our most amazing sponsor, Andrew Edwards. Andrew, can you please stand? Andrew is just a stunning contributor to this conference. I've been in contact with him on email for years, and he's always asking what he can do to help. And he really came through for this conference for us. And the general rules are nobody buys beers, or Andrew does not buy his own beer this conference. It's all on me, so if anybody catches him buying a beer, stop him. And it's on me. So welcome, Andrew, and thank you. Okay. We were lucky enough with this conference to have an embarrassment of riches. We had to turn away 2/3 of the proposals for talks. So the talks that are here are, well, it's one of the strongest technical conferences I've been to. So you guys we've got a packed schedule. We squeezed in every minute with stuff so we could get as many talks as we could in there, and we're really, really pleased at what we wound up with this. So I want to introduce the speakers. There's Ali. Can you stand up, please? Ali's written the second book, or I think the third book on D, and his interest is mainly in educating people about D. Robert Shadek from Germany. Good to see you. Dimitri, I got an email from him this morning. He couldn't make it. Oh, I was so looking forward to his presentation. What? Okay, where's Ben? Ben, okay, Ben's going to be replacing him. Okay, Manu, can you stand up, Manu? Yeah, okay. I visited Remedy Games. They're in Finland, and they're doing some really amazing work using D, and Manu's going to explain all about that here. So I think it's a very important project he was working on with them, and I think it's going to be, I heard about it all day, and I hope that you'll be as excited about it as I am. Leandro Lucarella. Stand up, there you go. His talk was swapped with Don. Don's is today. It's going to stay like this? Okay. So Leandro is also from Sociomantic. Hope I said that right this time. Representing our sponsors. Tomorrow, we got Ian. So stand up, Ian. Ian's the guy who built GDC, the GNU decompiler, one of the triumvirate of decompilers. And so he is a major contributor to the success of D. Martin Nowak. Where's he? There he is. I want to personally thank Martin for helping me out of a jam and getting the shared libraries to work on Linux. Awesome work. C# to D, Adam Wilson. Where's Adam? There's Adam. Adam's a fellow Seattleite. Vladimir Pantelev. Now, I don't know if you all know, but the D forum software that's on the website, forums.dlang.org, that's Vladimir's work. He's impressed everybody. It's a showcase for D about how you can write systems level code that's fast, effective, and leading edge. did really an amazing job with that. Rainer Schütze. Rainer Schütze has helped me a lot get the Win64 compiler to work correctly, and he's also the author of Visual D, which integrates the D in with Microsoft Visual Studio. And we have, proud to have Maxime Chevalier Boissert, I hope I said that right. Can you stand up, please, Maxime? Yeah. Who is doing research using the D programming language as a research tool. So, and we have Andrew, who's also giving a presentation. Oh, you can stand up again, Andrew. Falling down, or the birth of Acheron. So Andrew is working on a project he'd like to talk with us about. Okay, Don? Oh no, Don, compile time function execution. That's Don's baby. Don's been an enormous contributor to making that work and extending it, and has been doing fantastic work with that. Also, he's here representing Sociomantic. Stefan Roja. Yes. All right. David Simka. All right. David's a very prolific contributor on the news groups. And David Nadlinger. He's our third compiler guy, LDC, the LLVM-based D compiler, which is fantastic that we have 3 major compilers for D. Manu Evans, again, who is basically the impetus behind getting SIMD support in D. And he's very experienced at writing SIMD code, so his experience on the right way to do it and what works and doesn't work has been incredibly valuable to getting first-class SIMD support into D. Writing testable code, Ben Gertzfield. Yes. Are you giving a sec?
Yeah, so Andrew's going to go longer.
Andrew's going to go longer? Okay. And then Kuovedas, who I used to know what that means, but I forgot. By Andre, bringing up the tail. Where are you going? Okay. All right. So that's our schedule, and there's not a whole lot of room for anything else because we packed it pretty solid. So my next thing is, what is the point of D? Where does it fit into the universe of programming languages? There are thousands of programming languages, a few major ones, and what's D's place in the universe? And we can't be everything to everybody, so we have to pick some things that we're going to be good at and that we're going to be the best at. So what I see is 3 main things you want D to be, sort of at a step back at a meta level, is I want to make it easy to read and understand code. I've seen code written in other languages, and you look at it formatted like on the display and all that, and there's simply no way to format it so it looks nice on the page. Just no way to format it, and that just bothers me. The code should look nice. You should get this little squirt of a dopamine when you did it right and when it looks right. Okay? I mean, I still get that. I've been programming for a long time, and I still get that feeling when you get, and it's just perfect, How many of you guys get that feeling, when you write something, it's just perfect. And when you can't make it look right on the page, it just, you just kind of want to hide it somewhere, sweep it under the rug somewhere. Next thing I think is really important is the notion of being able to prove your code correctly, that your code is right. Relying on somebody reviewing your code to check that it's right just does not scale. It's not reliable. People make mistakes. They get tired. They don't want to review the code. It's boring. That's what computers are good for. They should be able to prove my code is correct. So we want to push that as far as we can. And the last thing is, if it's not industrial quality, people aren't going to use it. Because people say, well, that's a great language, but it's slow, I can't use it. If you're writing a game, you need top performance. If you're writing Facebook's infrastructure, you need top performance. Nothing else is acceptable. So we can't sacrifice industrial quality to get these other things we need. So let me expand a bit more on easy to read and understand. Part of it is, no, Andre doesn't like my metaphors, but think of an airplane design. The shape of an airplane. Who thinks the shape of an airline is beautiful? Okay? You see a 747 floating overhead, it's beautiful. It's a beautiful shape. And trust me, nobody designs airplanes to be beautiful. It sort of happens that when it's right, it's beautiful. And that's kind of what I'm shooting for. It's not, sometimes I see a custom car where they built all these flowing sheet metal and stuff, and it doesn't look right to me because there's no purpose to the shape, those flowing shapes of the car. An airplane, every aspect, every curve, every millimeter on that is optimized. And it's beautiful, and that's what makes it awesome. And I want our code to look like that. I want it to look right. An airplane looks like it wants to fly. My dad was a pilot for 23 years, and he said, that's the great thing about an airplane. A good airplane, you can look at it, you can see it wants to fly, you know it's going to fly. I'd like code to look like that. Let's see, code, it must look like it wants to be correct. That also means like minimal boilerplate. I don't want a lot of, surrounding garbage around the code to make it do what I want. And third thing is I want it to kind of look like the problem being solved. I want it to look like the way I think about a problem is the way I want the code to sort of look like the way I think about it. And these are all kind of vague, but maybe a couple of small examples will help. The corollary to code that looks right is right. Code that is bad code should somehow stand out as being bad code. Okay? I don't like languages where the nice slick code is always the wrong code and you have to do it this kind of convoluted way to get the right code. I want the right code to be the slick code and the wrong code to look kind of ugly and warty, like somebody, bolted something on top of their car. Something that looks like it doesn't belong. So here's a bit of what I'm talking about. This is an early version of the file reading function in D, and it goes back to D1. And it is correct, but you notice it's got these go-tos. And it's all there to handle errors. So if the allocation failed, if I can't read the file, if the close handle failed, I want to clean up the code, unwind things, and return some sort of error code. Now, this is shown over and over and over again to be an error-prone style of code. But it's hard to get away from that in most languages. You wind up with, a bunch of nested ifs, a bunch of go-tos. I was talking with Maxime earlier about programming language research, about constructs that people find hard to understand and constructs that make things easier to understand. Well, it turns out that this is a feeling I have, and I think it's also backed up by a lot of experiences. People think in a sequential manner. So if you can write code that simply goes A to B to C to D to E, it's much more likely to be correct code. So what we've invented with D, and that the scope thing comes from Andre, is we put the cleanup code. Here we check to see if it's valid. If it's not valid, or if we're leaving the scope because we had an error, we can execute this code. So here we do an allocation. If our scope leaves because it fails, we can make sure we delete the buffer. And so what you wind up with is code that there are no go-tos in it, there are no loops in it, there's no conditionally executed code, or it's all kind of hidden. You can think about it and reason about it in a straightforward manner, A to B to C to D. So even though what it's doing is not simple, it's much easier to understand and much less error-prone. And I've looked at other people's code written in other languages, and this error cleanup is where most of the bugs usually are hiding. And in fact, the Coverity C code analyzer, one of the big things that always is tripping on is those darned error recovery go-tos. Now, David will remember this. We were talking about a language and an IDE for it, and he said, the IDE is great. With one key, I can add 100 lines of boilerplate. And to me, that was a giant red flag. Something's wrong with this language if I have to if I need an IDE to generate 100 lines of boilerplate to do something useful. You shouldn't need an IDE to do that, or at least an IDE that adds boilerplate. The boilerplate, you should be able to design libraries and constructs and things in your language so you don't need boilerplate. I like it to look like the problem being solved. Here's an example of a modern, or D written in a modern D style, where what we want to do is we want to read lines in a file, and we want to sort them, and we want to write them the standard out. So it takes a file, sorts the lines, and writes it out. It's a very simple filter program. A normal program will be written in a bunch of loops and a bunch of checking for errors, reading the file, pretty much a whole bunch of nonsense and stuff to make it work right. But here, we can do this using A to B to C to D. We can think of the program like a pipeline. So our pipeline is, we're reading from standard in by line, and we want to keep the line terminator, whatever it happens to be. And an artifact of reading by line is it uses a single buffer for performance, so we want to map our lines to be separate allocations. That's what this line does. So we're reading by lines, we're keeping all the lines, converting placing all those lines into an array, sorting the array, and then copying the result to standard out. So no longer do we have a bunch of loops and checking for errors. This does everything. And you can look at it, and you can see that it's correct. You can also change things in there by pulling things out and plugging things in, and it will still, and you can redesign how the thing works fairly simply. So people have seen me a lot advocating or pushing on the news group that, ranges and component programming is kind of the future for a lot of different styles of programming, and D supports that style very well. Okay, next thing about Provably Correct is I want to be able to prove that my program cannot corrupt memory. Now, some languages like Erlang and Haskell and Java, they can give you a guarantee that memory is not going to be corrupted by your program. That doesn't mean you're not going to have bugs in your program. It means you're not going to have a certain kind of programs, certain kind of errors, memory corruption errors. So we want to be able to at least find a way to prove in a systems programming language that we don't have memory corrupting errors. We want to be able to prove purity and immutability. We want compiler support to do that. We want contract programming to verify that we don't have logic errors in our code, and we don't have what I call faith-based programming. We don't want to rely on thinking or hoping that our program is correct. We don't want to rely on training our engineers to be better programmers so they won't make mistakes. That doesn't scale, it's unreliable. You cannot always hire perfect people, perfect engineers. So we're going to try to rely on the language and the language tools more to make sure that our code's correct. So as I said before, memory safety means no memory corruption. Memory corruption are things like using a pointer after the memory it's been pointed to has been freed, writing to random places in memory, stack corruption, things like that. And it's enabled in D, because D is a systems programming language, it still needs to allow you to do unsafe things. So you can mark things with the @safe, and then the compiler enforcement of you can't do unsafe things kicks in, and it works by disallowing things like pointer arithmetic and inline assembler and calling C functions like freeing memory. That's an inherently unsafe function. And the other thing about safety is it's transitive. Another way of thinking about transitive is it's turtles all the way down. Safe code can only call other safe code. So that provable purity and immutability. Functional programming is kind of the new wave of programming ideas, even though it's been around for a while. It's really kind of come to the fore, and a lot of languages purport to support functional programming. But I would argue that they don't really. And they don't really because they don't have compiler checkable immutability and purity. Those are two of the pillars that functional programming relies on. And if your programming language doesn't support checking for that, you're back with faith-based programming. So if you have a top-level piece of code that expects this function it's calling to have no side effects, it's great to have the compiler check it, transitively turtles all the way down, that it actually is pure and doesn't have side effects. Otherwise, you're left with some maintenance programmer coming in years later, and way down in the call tree, they're going to set a global variable or something like that. And you, as the caller up here, have no idea this was done, and you have no reasonable way to check to see if it's done. So I kind of think of it as kind of, the gold standard, provable purity and immutability. You know for a fact that your code is not having side effects that you don't know about. Functional programming, as you'll often read about, has an excellent track record in producing reliable, robust programs. So we want to support that properly. And another nice thing about functional programming is it's a major aid to understanding code, because you know that when you're calling this function that's labeled as pure, that it's not going to have any side effects. And you know if you're passing around immutable data, it's not going to change. Somebody deep down in the system is not going to be tweaking that variable. So how many of you have had problems with code that had side effects you didn't know about? Yeah, pretty much everybody. It's time for that to come to an end in modern programming language, especially if you've got a large team and a lot of people working on it. Contract programming, sort of popularized by Bertrand Myers. There are limits to what we can check at compile time. Sometimes we've just got to check things at runtime. So what contracts are used for is used to validate that the logic of our program is correct. A common misconception is that contracts are used for validating user input. This is completely wrong. It's very, very important. Validating user input is not contract programming. Contract programming is checking to see that the logic of your program is correct and that the integrity of your data has not been lost. For example, if you're writing a function that takes the square root, your contract in there would check to see that if I square the result, I get the original value back. Or a contract on an assort function would actually check to see that the result was sorted. Sounds kind of dumb, but those are the basics. or sounds kind of trivial, but those are the basics, and it kind of goes on from there. The other neat thing about contracts is one of the barriers to optimization is optimization always has to make the most pessimistic view of your program and your data as the language specifies. And so a number of optimizations become not possible to use. But if you have contracts in there that constrain the number of, or the range of values a particular type or variable can have, the optimizer can use that to generate faster code. For example, if you're dividing longs, which is a 64-bit operation, but if you happen to know, or if the optimizer happens to be able to deduce from the contracts that the values are all fit in 32 bits, they can do a much faster divide operation on that. And there's a long list of arithmetic shortcuts that can be made if you can restrict the range of values. So it's not just for checking your code. It's also for an advanced optimizer, providing information to the optimizer to generate better code. Industrial quality. I talked a bit about this before. What would make a language useful for a large organization? Well, it's got to have no compromised performance. Everybody wants faster code. That every once in a while you read articles saying, you know, nobody cares about faster code anymore, but that's not so. People always care about faster code, even 1% faster code, because if you have a server farm that's costing you $100 million and you can generate code that's 1% faster, you've saved yourself $1 million. And that pays for, you know, quite a few engineers working on it to make it 1% faster. So even those little minor tweaks to make things faster are worthwhile. As Manu would attest, performance is everything in a game. So it's highly critical to even get the tiniest bits of performance out of a game. And so a language that doesn't deliver first-class, world-beating performance isn't even in the running. Another thing about industrial quality is it's got to scale to large programs. It's got to work on the small, and it's got to work on gigantic programs. So the language has to have an ability to scale. It has to have an ability so teams can work on code. And that gets into a language should support management tools. Things for companies to manage the software with, or a way to have automated tools run over the software to tell management things about it. So what can we do to get no compromise performance? Is part of that is having semantics that map directly onto the hardware. So we're not trying to pretend for the default integers that we have infinite precision. We don't. Some languages do that, but they're always going to suffer in performance when they do that. Instead, and we've talked about this, argued about it numerous times in the news groups about signed vs unsigned types. You know, we've got to map the semantics based on what the CPU delivers us, because that's going to give us our best performance. So even the SIMD types, recently we've added SIMD as a native type to the compiler, or to the language, I should say, because that's the only way you're going to get the best performance out of writing SIMD code. Another way to get no compromise performance is we're using modern optimizing backends, and as Ian and David are doing, that's why we're using LLVM, GCC, and the venerable old Digital Mars backend. It's a lot of the best compiler people in the world are working on those backends, so there's no compromise in performance when using those backends. We are getting first-class performance, as good as anybody. And the other thing is designing the semantics of the language so it is amenable, it's tractable for an optimizer to generate excellent code with. So we want to provide as much information as we can to the optimizer so it can generate the best possible code. So how do we get an ability to scale to enormous sized programs? One, of course, is separate compilation. Program isn't compiled as one gigantic unit, it's compiled as a bunch of separate pieces. Strong encapsulation means you can build a wall around your pieces and you can precisely define what crosses those walls. One aspect of that is there's no global namespace in D. Very important encapsulation feature. As soon as you have a global namespace, all of a sudden you have multiple parts of your program wanting to use the global namespace and stepping on each other. Anti-hijacking, which means, I have a whole other presentation about that. It means so that if you're importing modules that have similar functionality, your code that's meant to call functionality in one module is not going to be inadvertently overridden in the calling something completely different in another module. Voldemort types is kind of like that name, and it kind of caught on. Voldemort types is creating types that are completely hidden. Well, the name of them is completely hidden from the user. He does not even know the name of the type he is using. He just knows about its behavior. So I think that's a really neat thing to do with encapsulation, because if you can't name it, you can't compromise it. Well, not easily anyway. And of course, high-speed compilation. If it takes you hours or an afternoon to rebuild your system, it really, really slows down your edit, compile, debug cycle, and makes developing a giant program far more difficult. So designing a language where the semantics are amenable to high-speed compilation is very important. Management tools. I talked to a bunch of managers of teams of programmers, and they have a common lament is they want to enforce certain coding standards, certain documentation standards. They have to QA the code. So what can we do as a language designer to help that along? And a couple things that have been a spectacular success story in D is documentation generation. And that is, you write the documentation for code right next to the code, and then it is extracted by the documentation generator into HTML files, PDF files, LaTeX files, whatever. And it doesn't sound like much, but the difference in D's own documentation of the runtime library when we added this was night and day. An enormous improvement. There's a huge advantage to having these tools built in rather than being layered on by add-on tools, is they're always there, they work, you've got the proper version installed. And for management, it makes it easy to reject code that doesn't have the documentation for it. You can even automate that. So it's important, like for management, to say if you want to check in code, you have to have the documentation for the code in there. It can be easily checked for this scheme. And the same goes for unit tests. Instead of being an add-on tool or sequence, a set of conventions or best practices or a coding style document, it's built into the language. It's a fairly basic capability, but it's turned into one of the huge success stories of D that it becomes almost embarrassing to try to check in code that doesn't have unit tests in it. And if you try to do it, the first comment you'll get is, where are the unit tests? And so it's been a huge win for us. I've looked at a lot of projects written in other languages, and a common characteristic of them is they don't have unit tests. It's not part of the culture of those languages to have unit tests. And with D, by having these things built into the language, it's become part of the culture of the language to have them. Something I'm working on trying to get it more mainstream, is Coverage analysis. D has a built-in tool to say which lines of code were executed by your tests and which lines were not. It's hard to get 100% coverage of your lines of code, but my experience is that if you've got code that you've checked the coverage on it and redesigned your tests, so at least all the paths of code that you could reasonably test have been tested. As the years go by, it turns out there are remarkably few bugs actually show up in the field in that piece of code. It's more effective than you might think. You might think, well, just by executing this code, I'm not proving it doesn't have bugs. And you're right, you're not proving it, but in practice, it turns out that most of the time you get rid of all the bugs doing that. Coverage analysis also finds things like dead code and eliminates, and you can eliminate them from your project. Like, why is this code? Why it's impossible to execute this code? I should reevaluate it, why I have it in there. Maybe it's a bug that it's never executed, or maybe it's detritus that should be removed from the code. So I think coverage analysis is a management tool because the QA staff can look at the code and look at the coverage of the test and accept it or reject it based on your company standards of how much of your code should be tested by the unit tests. Very easy way to check that. It's even set up so you can integrate it into the build system. So your code fails to build if it doesn't execute a certain percentage of the code with the unit tests. And now we're working that into the build system for the D runtime library itself. So, in conclusion, I've been told from the start that D couldn't possibly succeed. Who am I to think that a major new programming language can be created? And we've done it. We built it. And you guys are the proof. D has fantastic support from the community. It's fantastic because it's international. All over the world, people are using and working on D and contributing to it. We switched to hosting D on GitHub, which is turned out to be a revolution as far as getting people involved in D and contributing to it. There's a very definite before and after we went to GitHub. So kind of a shout out to GitHub. What a fantastic collaborative distributed development tool it really is for us. As evidence of that also, which I hope you'll agree with me at the end of the conference, that we have very strong technical content for this conference. As again, like I said, an embarrassment of riches, the people who submitted proposals. And D will be the premier language for high performance, high productivity computing. And we're on our way, and this is just the start. So, any questions? So now's your chance. You got questions? Yes, sir.
Hi.
Hi.
Yeah, it's working. So I have a question about code coverage. So I used to use tool in the past that was checking not only the coverage of the code, but the branch you take. For instance, if you have if A or B, you can take the branch within the if in two different ways, if A is true or if B is true, right?
Yes.
Or you cannot take the branch. And you can easily test, only one of those cases, and you get 100% test coverage. But actually, you don't test all the cases where you go in or out the branch. So, do you plan to integrate this kind of metric into the coverage tool?
It already is integrated. If you run the coverage analysis tool, it will give you on a statement-by-statement basis. It will even give you on if you're using ands and ors, conditionally executed expressions, it will break those out and give you a execution count for each statement and each conditionally executed expression. So it will tell you how many times they executed. So you can also use it as kind of a rudimentary performance analyzer as well, because You can see how many times the code is executed. So I believe the answer is yes.
Is there,
Yes, sir.
is there a chance of extending the language so that you can return and use the carry bit or overflow bit, parity bit, those things from the result of an arithmetic operation?
Oh, that is an interesting topic. I've thought about that for a long time. For example, if you want to like rotate through carry and things like that, or if you want to multiply with an overflow.
Or an add that's more than 64 bits.
Add that's more than 64 bits. I haven't figured out a way that actually makes sense to make that work. One thing I have figured out, though, is people often do that stuff in C-like code, and they do it in particular patterns. So even though those patterns don't check the overflow, what the compiler or optimizer can do can detect that pattern and rewrite the whole thing using the carry flag.
But does D currently do that?
That's actually the job for the back end.
Oh.
So it depends
Pigeonhole
on, I'd say that's an implementation quality issue. Because if you'll see code that like checks for an overflow, C code that'll check for an overflow, like if you're looking at a safe int package or something, it generates specific patterns of things that you can recognize and then rewrite using the carry bit. And I think that is the approach that is most likely to work for that kind of thing. So, next question. Sir, there's a microphone.
So there's a runtime coverage. What about static time coverage? So could we have, for example, what code is tested by my unit test, and that should be known at compile time?
You can't know at compile time what code is tested by the unit test. And it has come up on the news group that one thing the coverage analysis doesn't do is test to see that all conditional compilation paths are executed, or that all declarations are used. So you can still have declarations and definitions and things that are not used if there's no executable code associated with them, or things like versioning and things like that. So that is not tested with the current coverage analyzer.
Is there any chance of getting the code coverage to be able to statically tell you what code is completely unreachable, like at compile time?
There actually is some of that already. If you'll notice, if you have a while one loop and you have no breaks in it, and you have code after the while loop, it'll complain about that. So it does a primitive flow analysis to tell you about unreachable code. But it's not, it could be improved, but it is there. I don't think it does it for and/ands and or/ors, for example. Yes, sir.
So while we're talking about unit tests, is there support for different dependencies during test time and actual runtime, like for mocking frameworks and things like that?
I don't understand the question.
I'll be the best. I'll talk to you.
Okay.
I'll wait.
All right. More question?
Could you mention a few interesting projects for which D is used?
Well, the Remedy Games project is one of the interesting ones, and
Like a wider range of projects, if you know.
I didn't hear what you
Like a
asked.
wider range of projects that you might know about that we don't.
Well, I know some people, I believe the sociomantic people are using it for numerical analysis work. The games work is high-speed, high-performance graphics work, very heavily using the SIMD stuff. There are people doing language compilers stuff in it, basically rewriting the decompilers in itself. So I've used it to develop a JavaScript compiler and interpreter with it. I use it for writing all kinds of stuff with it. And I suppose anybody want to raise their hand on a great project they're doing with D?
I just wanted to say quite a few people are actually doing bioinformatics stuff with it. So
I'm not sure what bioinformatics
yeah,
is.
it's like It's like statistics in biology, like DNA analysis. I'm not doing that myself, but there's quite a few, like I think David Simcha and also other people have been doing this, and it's quite interesting. So it's high performance computing, but in a very specific scientific environment.
Okay. And Maxime, of course, is using it for research. Anybody else have any fun projects they're doing in D? Interesting ones?
We are doing public transport passenger information in D.
Cool.
In Germany.
Okay. So anybody using embedded systems with it? Okay.
I wrote a retro games emulator, which emulates embedded systems.
That's awesome.
It's on GitHub.
All right. More questions? Yes, sir.
Thank you. As you should know, Walter, I've been teaching D in the university for a number of years now.
Mm-hmm.
And
this is Chuck Allison, by the way.
I think these people are too young to know who I am. So. Anyway, and you might be interested in knowing that a good number of my students have gone on to write their compilers in D. And their virtual machines as well. We still have a 2-semester sequence where they have to write their own virtual machine, and in the second semester they write a compiler that spits out the code to that. But since I have been teaching this, I just wanted to bring up in this forum an issue that the students have given me a lot of feedback on. I think I've got them all pretty excited about D. It's kind of infectious, you know. As you know, I'm excited about it. But this generation of students is also, you know, that, what do they call them? Generation, the millennials, I guess, and they're used to these helicopter parents, and they're used to having everything handed to them. And so they're all saying, what is a good IDE for D? That's number one. You know, they want the hand-holding Visual Studio type environment. And then number two is, they say, there's no good documentation on D. I can't just quickly look up stuff and get everything I need to know. So maybe there's some things we don't know about. If you could comment on those two things, that will help me help my students. Development environments and online documentation that is easy for students to use. Thank you.
Well, I think that's an excellent question. We're almost out of time, so I guess that will be the last one. Online documentation is a constant area where we're trying to improve it. We've seen some other online documentation for other languages that we'd like to emulate, and because they do a much better job of it than we do. That's a definite needs improvement for us. We do have a fantastic book written by Andre, which
We
you all know
actually
about.
use that. I would imagine we're one of the few universities that have that as a required textbook.
Cool.
But it is also out of date already, as you know.
Well, Ali is working on a book.
Actually, I've been contacted by a college professor. They're using CS2. A CS2 course will be using my book, apparently, for textbook.
Oh, really?
And yeah,
Wonderful.
that was actually.
And I would love to see that. The beta's online, right?
My book is online, yes.
Yes, okay.
Yes,
Good.
everything is free online. PDF version and HTML version are online.
Say that again? Oh, for the recording. Yeah, Ali just said that his entire book is available online.
Yes.
Okay.
Okay, for IDEs, we have Reiner, who is doing a Visual Studio plugin for D. And I'm sorely tempted to say that real men don't use IDEs, but you know.
And I agree. I totally agree with you.
I'm kind of dating myself with that. It's a definite area of needs improvement for us.
Right. I would just like to say that it's interesting. This is a senior course that I teach, and I have to educate them on how to use the command line. Amazing.
Well, what can I say?
Yeah, not all of them.
Okay. All right. Well, I guess I don't want to intrude on the next speaker's presentation, so that's it for now. So I guess we'll have a short break and we'll be back here at 10 for Ali's. I think Ali's next.